right, today we're going to be looking at what are called permutations. So our introductory activity says, you are in charge of planning one of the most anticipated concert tours of the summer at First Niagara Pavilion, which will include Drake, Rihanna, Beyonce, and Kanye West. One of your jobs is to determine the order in which the artists will perform. How many different ways can you put together this 4-artist concert? So we have 4 different artists to choose from. So how many choices do we have for the first performance? We'd have 4 choices. Okay, then we would put somebody there. How many choices would we have left for the second performance if we put somebody here? We'd have 3. When we put somebody here, we'd only have 2 left. And then finally, 1. Using our fundamental counting principle from last section, we then just need to multiply those together. So it should be 4 times 3 times 2 times 1, which would be 12 times 2, which is 24. So 24 different options for how we can arrange the singers' performances. So a permutation, by definition, is an ordered arrangement of items that occur when no item is used more than once, and the order of the arrangements makes a difference. So again, permutation is when the order matters. Using the same example above, let's assume that the event coordinator has determined that Beyonce should be the last artist to perform and close the show. So I'm just going to put Beyonce right here. She's going to be closing the show. Given this decision, in how many ways can we put together the concert? So if Beyonce is already slated to be here, how many choices would we have to pick from for the first, second, and third performance? We'd have 3 choices, then 2, and then 1. So again, using that fundamental counting principle, we would have 3 times 2 times 1, which is 6 different ways. And then this one gives us another stipulation. So assuming that Drake should open the show and Beyonce should close the show, how many choices do we have? So let's put Drake here and let's put Beyonce here. How many choices would we have left for performances? We'd have 2 choices and 1 choice. So that would just be 2 different ways if we rearranged those artists. So you can see the more stipulations, the fewer possible combinations that we would have. Why don't you go ahead and try number 2? You need to arrange 5 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? Go ahead and pause the video and complete this problem. Okay, coming back together, we should have had 5 times 4 times 3 times 2 times 1, which is 120 ways. Now what we're going to talk about next is called a factorial. A factorial is a faster way to perform this mathematics so that you don't have to do 5 times 4 times 3 times 2 times 1. You can actually use the factorial key, which looks like this. It's an exclamation point. The exclamation point tells you that you're going to multiply by all the numbers smaller than 5 all the way down till you get to 1. So a factorial of a number is a number multiplied by all of the numbers less than it until you reach 1. So let's do 5 factorial using our graphing calculator. Again, this really would be equal to 5 times 4 times 3 times 2 times 1. But without having to type that in our calculator, we can just use the factorial key. So in our graphing calculator, the first thing you will have to press is the number 5. And then to get the exclamation point, which is our factorial, we'll press the math button, which is located right here. Arrow over to the probability column, which is what we'll be using all of this chapter, and arrow down to number 4. So we should see 5 exclamation point on our screen, and when we hit enter, we should get 120. So again, that just saves us from having to type out that repetitive multiplication. All right, in example 3, we are going to evaluate the following factorial expressions. It says without using the factorial key. I won't know if you use it at home, but I'm going to teach you both ways because sometimes your calculator will get you an error. So 8 factorial. Remember, this is the same thing as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we were to expand it all out. And 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1. And then if you notice, we have common elements in the top and the bottom. The 5s will divide out the 4s, the 3s, the 2s, and the 1s. So we're just then left with 8 times 7 times 6, which is 336. Now some students will say, Mrs. Bennett, can I just type that in my calculator? Yes, you can. For this one, 8 factorial divided by 5 factorial, and we will get 336. However, please pay attention to letter B. I want you to change this example to be 200 factorial over 198 factorial. There is one similar to this in your homework and on the mini quiz. I don't want you to get it wrong. So pay attention. If you were to type this one in your calculator, let's see what happens. You will get what's called an overflow error. That does not mean that you can't do this problem. It just means that your calculator will not do this problem. The numbers are too big. Okay, be careful because on the mini quiz, one of the options is undefined as an answer. That is not the answer to these problems. So you will have to expand by hand. So when you get an error, you must do this problem by hand. So I'm not going to actually write out 200 times 199 times 198 all the way down to 1. What I'm going to do to shortcut that is I'm just going to write 200 times the next smallest number, 199, times the next smallest number, 198. But I'm going to put a factorial on that because 198 factorial is really 197, 196, all the way down to 1 without having to write it all out. Now the reason I stopped at 198 factorial is because the denominator is 198 factorial. So then you can technically cancel out the 198 and the factorial symbol. So we're just then left with 200 times 199, which is 39,800. Again, there will be one like this on your mini quiz. So please pay attention, put some stars here. All right, and then that last one, we have 4 factorial over 6 factorial. So in the top, I can write out 4 times 3 times 2 times 1. And in the bottom, 6 times 5 times 4 times 3 times 2 times 1. And again, cancel out your common elements. So the 4s, the 3s, the 2s, the 1s. And be careful, your answer is not 30. In the top, you are actually left with nothing, really, which means there's an imaginary 1 hanging out as a placeholder. In the bottom, we have 6 times 5, which is 30. Now, if you utilized your calculator to do this one for you, which you could, you would need to convert it to a fraction. So 4 factorial divided by 6 factorial. You'll get this decimal. Remember, to convert back to a fraction, we press the math button, fraction, and it will give us 1/30 as our answer. All right, if you're filling it up to it, go ahead and try example 4 on your own. Pause the video, and then whenever you're ready, press play, and you can see me go over these examples. So go ahead and press pause now if you'd like to try them on your own. All right, coming back together. This one we should have expanded. Again, if you want to use your shortcut, we can just expand the 987 times 6 factorial because the 6 factorials will divide out, leaving me with 504. In example B, expand the top until you get to 11 and then leave the factorial symbol so that the 11 factorials divide out. Should get 5,000 or 524,160. And in example C, I expanded out the top and the bottom. Again, make sure you realize that when all this stuff goes away, that you are left with an imaginary 1 in the top. And then we just need to multiply 7, 6, 5, and 4 together to get 1 over 840. Closure says, how is a factorial useful when finding the number of possible arrangements? It's really just a shortcut. So a factorial is useful to make calculations shorter when finding the total possible arrangements of a permutation. Again, remember your factorial button is found under the Math menu, over to Probability and option 4.